Hello, my name is KaineDiehl. I'm a student at West Liberty University. My poster presentation will be a behavioral study on Lacuni cambaris in a field setting. So, crayfish respond rapidly to environmental changes. This responsiveness to environmental changes makes them good detectors for degradation in the environment. Contaminants in the environment may influence crayfish by changing the physiological or what this project is on behavior. This study was conducted on Lacuni cambaris tomi in a field setting to gather information on the life history of a primary burrowing species of crayfish. Some pre-existing information on the behavior of and parts of the life history of L. tomi were incomplete and, in some cases, incorrect. The data showed that what was perceived to be a fully nocturnal species but had no data to support these claims based on field settings. This project provides a better understanding of the life history of a primary burrowing crayfish species. The results of this study could be used to get a baseline of the basic life history of these animals as well as other types of primary burrowing crayfish species. The introduction. Crayfish have historically broken up into three categories: primary, secondary, and tertiary burrows. The difference in these have to do with location of the burrow in relation to water source as well as the complexity of the burrow itself. Primary burrows with the preferred habitat of wetlands, seeps, springs, and roadside ditches. Usually they are found in complex multi-chamber burrows that follow the water table. Tertiary burrowers living in streams and making very shallow, simplistic burrows that are commonly made when streams dry up and follow the water table, and secondary burrows follow the middle ground of these two. Due to the elusiveness of primary burrowing crayfish life history, no studies on behavior have been done on these crayfish in a field setting. The purpose of this study was to collect data on the natural behavior of Lacuni cambaris tomi in a field setting. The study was conducted in a man-made impoundment in western Pennsylvania utilizing video surveillance to record the crayfish 24 hours a day. In Figure 1, we can see the location of this site. With this project being the first of its kind, it was able to shed some insight on the activity patterns of primary burrowing species. So, methods. Cameras were placed upside down in 5-gallon buckets set on tomato stakes above burrow entrances. This was done to protect the cameras from inclement weather and to control the light exposure. Cameras were set to record 24/7. Videos recording were then stored on external hard drives for later analysis. Videos were observed to create an ethogram that was then used to collect data for future videos. Statistical analysis was then ran using RStudio to show the activities, when activities performed and when they were performed, and the duration. These data was then used to draw conclusions about general behavior and night versus day propensity. As you can see in Figure 2, this is what an example of a camera setup would look like. The results, if we look at Figure 3, it shows an increase in diversity of behaviors and increase in above ground and activity during the night. If we look at Figure 4, it shows a propensity for underground behavior during the day. And if we look at Figure 5, the table shows what activity was being tested for and then the light level when it was being tested. So, discussion. In total, 6 different crayfish had activity budgets created for their behaviors with varying total times. Between the 6 crayfish, 633 hours of observational data was collected. Each of the 6 crayfish had their activities graphed in a double bar graph, as was talked about in Figures 3 and 4. And then chi-squared test for normality was employed to see if the distribution of behaviors was equal between themselves. The tests were then ran during the day and night separately to see if there was a propensity for either. The p-values for all these were 2.2 times 10 to the negative 16th power, showing they were saying that they were not normally distributed. So if we look at Figure 6, we can see the crayfish having an intraspecies interaction with a garter snake, and we can also see in Figure 7 also a raccoon interacting with the crayfish by reaching its hand in the burrow to get the crayfish. We also then used chi-square test and then a two-tailed t-test with greater or lesser alternate hypothesis using day versus night activity propensity. The alternate hypothesis was set to see if what was expected was true. The tests were done to see if light affects the above ground and below ground activity, to see if they were truly in fact nocturnal. What was to be expected to be seen was an increase of above ground activity during the night versus the day, while more time below ground during the day than above ground during the day. While above ground activity had higher duration during the night than below ground activity. Overall, the test showed that the crayfish would be above ground more during the day than in the night, and would perform more during the night than the day, with the total amount of diversity in the activities that were performed.